Welcome everybody to the Building Lightning Components Deep Dive section. We're going to talk today about some more advanced topics on Lightning Components development. So if you're not familiar, don't have a lot of experience with Lightning Components development, I highly recommend you guys to take a look and sign up for the Introduction to Lightning Components sessions on your Dreamforce app as well. My name is Rodrigo Ribucas. I'm a senior ISV technical evangelist at Salesforce. And before we start, Salesforce is a publicly traded company. Please make all your purchasing decisions based on current available functionality only. So here's our agenda. We're going to start talking about Lightning events, all the different types of Lightning events that are available for you guys as developers to handle and to fire from your custom Lightning Components code and do all sorts of interesting things. Then we're going to talk about Lightning-based components, which are these awesome building blocks that really help speed up your Lightning Components development. Then we're going to talk about Lightning Data Service, which is a very cool new addition to the Lightning Components framework, which is now GA with Winter 18. This basically puts, if you guys are used to Visualforce, it puts a standard controller inside your Lightning component, so you don't have to write any Apex code to fetch, record, and perform CRUD operations. And lastly, we're going to talk about dynamic Lightning components. So this is a very cool technique. If your Lightning components are starting to get very complex, if you're creating different child components inside a parent, for example, you may want to use this technique to make your components more flexible and performant. So let's start with a quick recap of the Lightning Components framework, right? So Lightning Components are these loosely coupled application modules that you guys as developers create. And your admins may install other Lightning components from the App Exchange, or other developers can create other Lightning components. And then your admins are able to put them, use the Lightning App Builder to put these small app modules, right, the Lightning components on a Lightning page, and somehow they work together. And that creates a very rich user experience with very customized user experience, something that you had to redraw an entire Visualforce page before for different audiences, right? So that allows for this plug-and-play development approach. So Lightning Components changes the pattern of development a little bit, because now you're developing parts of the user interface and not an entire page anymore if you compare with Visualforce, right? So that's great. We can put all these little app modules inside a Lightning page, but somehow they need to work together, right? So that brings us to the first topic of today's session, which is how these Lightning components actually communicate, right? And that's using Lightning events. So Lightning events allows you guys to share data and communicate with Lightning components that you own, or the Salesforce owns, or the other developers owns, using events. And also to respond to user interface events, to the Lightning Framework system events, which we're going to take a look in more details later on. But here's an example, right? Another type of event that we're going to take a look is navigation, right? So you want to take users to different places on the Lightning experience in Salesforce Mobile, so you can leverage navigation events to accomplish that. So here on the diagram, you see basically a visual representation of the eventing system of the Lightning framework. So component A fires an event, and then the framework basically distributes this event to other components that maybe want to handle that event. So that's representation of that. And when we talk about events with Lightning, this can be a little confusing, because there are actually 5 different types of events. So we have browser events, system events, navigation events, component events, and application events. So for today's session, we're actually going to use a very cool Lightning component that my team has created here at Salesforce, which is a custom ListView component. And here's the architecture, right? So what you guys see here on the screen is the parent component from our ListView that holds the header, holds that new button there on the top right, and holds the column headers for our list, right? And inside this parent, we basically create different instances of this child component named ListView row. So here's how it looks whenever it's rendered. But enough of slides. Let's take a look at that in action. So here is the recruitment application that our team created for these demo purposes with partners and customers like you guys. And here, if you see here on the top right, we're looking at the interviewer console page. But on the top right here is our ListView Lightning component right here. But I want to take you guys to the code of this Lightning component real quick, because I want to show you the approach that we use to create those child Lightning components on our case here. So this is the markup for our parent Lightning component here. Let's scroll down to the very bottom, because I want to show you something that you guys may be familiar with, which is the approach that we use to create the child components inside our parent. So here we're using this aura iteration tag, which basically, it's similar to Apex repeat in Visualforce, but basically loops through a list of record that you guys may have retrieved from the server. And then we have different if statements here, but we basically create this ListView child components with this reference here inside our parent with each iteration in our list here. And this is a pretty trivial approach. The reason why I'm showing you is because I'm going to show you another approach later on in the session as well. Right, so let's go back to our deck. Because I really want to talk about the first of those 5 types of Lightning events that we touched in the beginning, so which are browser events. So browser events, they are not particular to the Lightning framework, as you guys may know. Every web technology or web stack has that. So they basically are browser notifications regarding an action, and they're triggered by user interaction with an element in your components, usually an HTML tag. So here's an example, right? So in our ListView component, we have the column headers, the name and action, and we got a requirement from our project manager saying, okay, whenever the user clicks on those column headers, we need to basically sort our list, right? So we use a browser event handler, the onClick event handler for that. Whenever the user clicks on that, and you guys can take a look at what happens on the experience there, when the user clicks on the name columns, we basically invoke that c.sort grid in our parent component local JavaScript controller. And then with JavaScript, we're able to sort the list, right? So this is pretty trivial. I just want to show you because this is one of the types of events. And now let's talk about system events. So system events, they are fired by the Lightning framework during a Lightning component's lifecycle, right? And they indicate component state. So it's important for us as developers to know the different states on a Lightning component lifecycle, so we can do a lot of interesting things with code, right? And here are 3 of the system events in this particular order that are fired by the framework and that you guys as developers can handle on your custom components to do, different use cases. On today's session, we're going to show you an example on how we leverage the render system event. And I'm also going to show you guys now how to look at the documentation. It's important for us as developers to know what are the system events that are available for us to handle, right? So to take a look at this list of system events, I highly recommend you guys to go to the Lightning Components Developer's Guide. So once you're there, you basically search for system event, and you get to this page, system events, which basically has the list of all the system events that you guys can handle from your custom Lightning Components code, okay? So you will see things like value change, value init, which is a pretty common one, which is that init event handler that you guys may be familiar with. For today's session, we're going to show you an example of how we handle the value render event, or render event, which indicates that an app or component has been rendered or re-rendered. So let me show you how we use that. So let's go back here. I have actually isolated our ListView component and its own tab, so it's easier for us to look at the demo. But basically, our project manager gave us a requirement, right? They said, okay, whenever the list loads, we want the first record in our list to be selected by default. So our development team got together and we say, oh, that's the perfect scenario for us to use a system event, because we really want to basically put a CSS class on that first child ListView row whenever after our component is rendered, right? So that was the use case. So we look at that documentation and we saw we can use the render event for that. So let me show you how we did that in code. So first, when we chose the system event that we wanted to use for this use case, we added this aura handler tag, right, to our parent component. And whenever our parent component handles that, whenever the Lightning framework indicates that our component has rendered, we're going to execute this onRender action in our controller here in our parent level. So let's take a look at what that does. So onRender. So basically, whenever we execute this action here on our parent's controller, we basically use JavaScript to component.find to find that first HTML node in our parent's HTML DOM tree by its RID. So we find the first node, the first ListView row child component by its RID, in our case row 0. And then we basically use a.u2.add class to add to that node this Lightning Design System SLDS is selected CSS class dynamically. And that's basically how we're able to make this first row here selected by default. So that's an example of system event. Now let's go back because I want to talk about navigation events. So navigation events, they basically enable component interaction within the Lightning experience and the Lightning mobile experience, the Salesforce mobile experience. So you guys may not be aware, but Salesforce internally, all our CRM components and our platform components, the standard components, we use navigation events to open up models. Let's say the user wants to edit a record. We open up a model in the Lightning experience or Salesforce mobile with the fields that the user can make the change, or a new model, or even taking the user to a Lightning page or to a Visualforce page. So these are special types of events that we call navigation events. And here are some examples, right? So force navigate to URL is one of the examples that you guys can use to take the users to a Visualforce page or to an external website, opening a new browser tab. Force edit record and create record. These are events, navigation events that you guys can use to leverage those modals that I just mentioned. The create new record modal or the edit record modal that Salesforce already made it available for you. You just need to invoke those and fire those navigation events. So if you look here at the monitor, you see that when the user clicks on that new button, this modal, standard modal, opens up inside my custom component without me as a developer having to create this modal because this is part of the platform, right? I just needed to know which navigation event to fire from my custom component to bring that experience to my users as well. Okay, so let's take a look first. How would you know which navigation events are available for you guys to leverage, right, as developers? So how many of you guys know about Aura docs? Raise your hands. Yeah, it's just a few. It's not something that we broadcast because we have the Lightning Components Developers Guide, but it's a very cool little application that is available inside all the developers org. So that's why I want to show you guys, because sometimes it's handy. So if you open another tab on your developer orgs and you type in, after the force.com part of the URL, you type in Aura docs, and you can put this anchor tag reference. This very cool Lightning application opens up inside your developer org that has basically the documentation for everything in the Lightning framework that is available for you as developers to use. Okay? And you see here on the left, we have this navigation bar. And you can expand events, for example, and you can look at all the different namespaces of events that are available for you guys to use. So our development team got together. We got a requirement to create a new button to open up the modal. So we started exploring our docs and these events here, and we found this force namespace, which basically holds all these special navigation events. And we accessed the documentation page by clicking on create record here. We accessed the documentation page for the force create record navigation event. If you look at the description, it's an event fired to show the full record create panel, right? Which sounds exactly like our requirement. So we even went down, scroll down here on the documentation page, and you see that basically you have 3 attributes that you can set on this event. I'm going to show an example in code, but it looks like the only required attribute that you guys need to set before firing this event is the entity API name. Basically the API name of the object that you guys want to load the fields in that modal, edit modal, in this case, the create new record modal. All right, so let's take a look at how we did that in our code. So let's go to our parent component here, Markup, and I want to show you guys where that button lives, that new button lives, which is right here. So first we added a browser event on-click event handler, which when a user clicks on that button, it invokes this create new record action, right, in our parents controller here. So let's take a look at what we have there. So create new record. So since we know already the navigation event that we want to fire, we basically use a.get to basically instantiate that force create record event that we just saw the documentation page into a JavaScript variable, right? And now we need to set the parameters. Remember, there was only one required attribute, the object entity API name. So we, in our custom Lightning component, we knew the object API name. So we basically set the entity API name attribute with our custom component object API name. And then we simply fire this event, and then magic happens, right? That modal opens up. So this is pretty cool. This is an example of navigation events that you guys can leverage on your custom components as well. And now let's talk about component events. So component events, they're very useful whenever you have these parent and child hierarchy scenarios with Lightning components, in our case here. And it's very useful whenever you need to basically bubble up or pass information, communicate something from the child level components to the parent component level, okay? As you can see, component events, they can be handled either by the Lightning component that fires that component event or by any parent component in the hierarchy, right? So I want to show you what the requirement that we got from our project manager was and why we decided to use a component event, right? So let's go back here to our list view, and here's the new requirement. So our PM said, oh, you guys need to add a button group to each row in our list, and the user needs to be able to remove that record from the list. Okay? So as you see here, when they click on remove, the record gets removed from the list. And then we said, oh, that's great. So you know what? This button group lives on the child components level markup, right? And somehow, if you think about it, the parent needs to be able to remove that child from the entire list of child components, right? So this is the perfect use case for Lightning component events. So let me show you how we use component events whenever a user clicks on remove here, in our case. Now let's access ListView row.cmp, which is our child components, our ListView rows. And I want to show you guys, first I want to show you that we decided to create for this use case a custom Lightning event of type component. So here it is, we just said create new Lightning event. Notice that we set the type as component, again, perfect for this bubble scenario that we want to do from child to parent. And then we set our own data structure with the information that we wanted to basically broadcast from child component to parent components level. So we set an attribute for the record ID that we want to remove. The action, remember there were three actions, edit, view, and remove, so we need to know which action the user selected. And the index row of that child component, which the user wants to remove from our parents' list of components, right? So we created this custom event, and then at our ListView row child level markup, we then registered that we want to fire this bubbling event using our register event tag. We register we want to fire this bubbling event at some point, right? So let's take a look at how we did it. So if you scroll down here, here's our button menu group, right? And here's our remove. So we have here on the button menu event handler, we have a browser event handler for the onSelect. So whenever the user selects one of those options, we want to execute this handle list manual click action on our child's Lightning component controller, right? So let's take a look what happens there. So handle list manual click, here it is. All right, so basically we have a switch statement, right? So we have a JavaScript switch statement to basically figure out if the user clicked on edit, view, or remove. And if the user clicked on remove, we basically instantiate that bubbling action event using component.getEvent into a JavaScript variable. And now, remember that we had 3 attributes, right, that we set in our events data structure. So now we need to set values to all these 3 attributes before firing it. So we set we use component.setParam to set that selected record ID with our record ID. The child action, we pass it as a remove in this case. And then the index row, we pass it into the index row attribute of our custom component event as well. And then we fire that bubbling event from the child components level. So now remember, this is going to bubble up to any parents in our hierarchy, right? So let's go back to our ListView row and take a look at what happens there, okay? So here's our ListView component, the parent. Notice that in order to receive that bubble lightning event, that lightning component event, it also needs to have a handler, right? An R handler tag to that same bubbling event, right? Here's the event type, list row bubbling action event. And whenever any child in our parents components fires that bubbling event, we're gonna execute this handle bubbling action JavaScript action in our parents controller, right? So let's take a look at that. Handle bubbling action. So this is one. All right, so basically, whenever we handle that bubbling event, we first grab the parameters from that event, right? This is the way that we're able to receive the record ID, and the index row, and so on. So we grab the parameters on the parent level, and then we added another switch statement, and then we inspect what was the action that came on that bubbling event, right? Was it a remove action? If it was, we have this switch case if it's remove. We basically use JavaScript list.splice to remove from our parent's HTML DOM tree exactly that parent that the user, that the child component indicated through the bubbling event that the user wants to remove. So that's how we use component events to accomplish that. All right, so now let's talk about application events. So application events are very useful whenever you need to pass communication or integrate between Lightning components that do not necessarily live on that nested components hierarchy scenario, right? You don't have a parent and child. You just have Lightning components that live on the same level, maybe inside the same parent, or maybe inside the same Lightning page, right? They don't even need to be under the same namespace for you guys to use application events to send communication or integrate between these Lightning components. And application events, they follow a publish subscriber module, meaning that one Lightning component fires the event. So you can see here on the monitor, component A is firing this application event of type event X, and only the Lightning components that actually subscribe to that same application event type are going to be able to handle and receive the information that component A is sending. So notice that only components B and component E can actually handle this Lightning application event, and components C and D, they don't know anything about that application event, even though they can live on the same Lightning page, right? So let me show you how we use that in our use case. So let's go back to that interviewer console Lightning page. And notice that, remember we have our list view here on the left. So our project manager gave us a new requirement. They said, you guys, we need to create a Lightning page, and we need to put our list view custom Lightning component. And whenever the user clicks on each of the rows in our list view, those other 2 Lightning components, the Twitter Explorer and the referrals Lightning components, they need to refresh with the contextual information from the candidate, right? In our case, that we're loading in our list. So notice what happens when we click on list Brooks, for example. The Twitter Explorer refreshes with list information from Twitter, and so the referrals list from list. So our development team, okay, that's the perfect use case to use Lightning application events, right? They're not parents of each other. We just need to communicate with the same event type. So so our development team actually was thinking, should we build a custom Lightning event like we did for that bubbling event scenario on the component event type? Or should we maybe look and see if Salesforce already created a standard Lightning application event for that, right? It seems like a pretty common use case. You just need to pass a record ID, right? Most likely Salesforce has created that. So actually inside our docs, we started digging into these events node, and under the LT and G namespace, we started looking at all the standard events that Salesforce has created, and we found this select as object application event. If you look at the description, it sends a record ID when an object was selected in the UI, right? Which seems like it's what we need. And it looks like it only has 2 attributes that we need to set to use that as our messenger, right? To share the record ID. Just the record ID is the required attribute. And we can also set this channel attribute, which is a string, basically an identifier of which Lightning component is firing this Lightning application event. So let me show you how we did that in our code. If we go back to the ListView row, remember, when the user clicks on a row, we want to send the record ID to the other component. So we actually added a handler on the child components level, because that's where the user is clicking. So we added a handler here to the auto register event of type LT and G select as object, right? Which is that standard event that we found in our docs. So we know that we were going to fire that at some point. So now we need to handle the user click on the row, right? And inside its child components markup, the user is actually clicking on our table row here. So if you look here, we have added on our table row tag, we have added a browser on-click event handler to basically execute this fire row click events action in our child components local controller. So let's take a look at what we do there. All right, so fire row click events. So basically, here we use standard JavaScript to basically grab the record ID that we have inside that TR HTML node, right? So we grab the record ID by using dataset.record. And then we basically instantiate that standard event that we want to use to share the record ID with other components, so LTNG select as object, using a.get into a variable. And then we set those 2 parameters, right, that we had to available to set on that standard event. So record ID is the record ID that we grabbed from our HTML DOM. And also, we're passing here an identifier that we're firing this from our ListView row Lightning component. So other components that subscribe to this event can actually know which component fired that. And then we just use component.fire. And remember that by doing that, only the other Lightning components that are actually subscribing to this exact same Lightning application event type will be able to handle that. So let's go back here to our page, because now we just want to take a look real quick what happens on the Twitter Explorer side, right? On that other component that maybe we didn't even own, right, as developers. So if you look at the code for a Twitter Explorer, notice that here at the very top, it has a handler to the same, let me remove this from our side, to the same type of Lightning application event that we use from that other component to share the record ID. And then whenever it receives this standard component, it invokes this handle application event action on the Twitter Explorer side, which I'm not going to go into details, but basically calls an Apex server-side controller, which makes an API call to the Twitter API and returns the Twitter information to this Twitter Explorer custom component. Okay? So this is an example of how we use application events in our case here. And now let's talk about base components, right? As I mentioned, base components are these amazing building blocks that Salesforce is making more and more available with each release. We have delivered over 80 base components so far. Just on this last release, Winter 18, we released over 38 base components. And they are the building blocks that you guys as developers can use inside your custom Lightning components to create basic things, right? So think of an avatar, for example, or think of a checkbox label or a button menu group, right? When the Lightning framework started about 2 years ago, we actually didn't have much of these building blocks available. So we had to create most of these things from scratch with HTML, with CSS, with JavaScript, Now Salesforce is making a lot of these building blocks available to you guys to speed up your development. With CSS, with the Salesforce Lightning Design System styles automatically enabled, with JavaScript, with data validation, data binding on some of them. So, and you guys can access them and use it inside your custom components using this Lightning namespace. So if you guys go to Aura Docs under Components and Lightning, those are the base components. And let me show you how to look at all the base components that are available for you guys to use today. So if you guys go to the Lightning Components Developers Guide, again, and search for base components here on the search box, and if you click on this page, working with base components, you basically open this page here that has all the base components, these building blocks that are available for you guys to use and speed up your Lightning component developments a lot. So we have things like accordion, cards, layout, which is our grid system, tabs, button. I want to point out that a very cool one just became available, which is a data table. So Lightning data table, if you click here, you get to the documentation page and shows you how to use it and so on to create a data table. So if you think of our ListView here, it's actually a data table. It's a grid, right? And when I first created it like a year and a half ago, we didn't have Lightning data table. So I had to create everything. It took me a lot of time, like style with Lightning Design System and so on. Do all the data binding using an Apex server controller. Now you guys can create something like our ListView here with Lightning data table based component like in 1/10 of the time that it took us. So this is pretty cool. I want to show you as well Lightning button menu, which is the one that we actually use here in our ListView component. So our PM said, oh, you guys need to create like, a drop-down that shows a list of action, right? Remember that remove, edit, and view action on each ListView row? So because the request actually came after Lightning button menu base component became available, we decided to use that, and that we could create this like in like a few hours, if not minutes. So we grabbed this example here. We have some code samples. It has examples of the browser events that it fires and how to handle that select browser event. Okay, so that's what we used. If you go to our ListView row, and if you look at that ListView row markup, I just want to show you, here it is, Lightning button menu. That's an example of base components that we used, and we were able to create that button menu really quickly. Okay? So definitely check out the Lightning namespace under Aura Docs or this documentation page, because you guys will be able to develop Lightning components much faster by using base components. Now let's talk about Lightning Data Service. Okay, Lightning Data Service, it's actually, funny enough, it's another base component. It's called Force Record Data. It doesn't render any UI, but it does a lot of very cool things when you reference this Force Record Database component inside your custom component. So basically, if you guys are used to Visualforce and you have the standard controllers, right, on Visualforce pages, where you basically are able to fetch data from the Salesforce org, perform CRUD operations, do all data binding without having to write an Apex class. It's a similar concept. You're able to create a custom Lightning component and do all that without writing a single line of Apex. But it also has some other two cool implied benefits. Share record cache. So behind the scenes, you guys notice that Lightning has become really fast with the past 2 releases, right? And share record cache is one of the main reasons of that. We implemented a very smart cache system in Lightning Experience and Salesforce Mobile. And by using Lightning Data Service, you guys are basically able to put your custom components using this share record cache as well. So think about if we want to make a change to a field value on a custom object, right? Behind the scenes, Salesforce is already using this share record cache in Lightning and Salesforce Mobile. So we don't want all the other CRM components to go to the Salesforce server just to grab the new field value that the user just made a change, right? So that's the reason why we created this share record cache. And this really speeds up performance. Here's an example. So the user makes a change on a field. the CRM object here, component here, in this case the detail component, writes to the share record cache. And I created this custom component, which is a graph that you guys are going to see here. And that is using forced record data, the Lightning Data Service, which is looking at the same cache. And then we are able to receive that information automatically without having to make a single trip to the Salesforce server, which helps with performance a lot. And also, something else that we're working on with Lightning Data Service, which is pretty exciting, is offline support. So basically, the idea here is that the user will be able to basically use a Lightning page with all these Lightning components that use this share record cache, even if they lose internet connection, right? And then we have a smart sync technology that whenever connection is back on, we basically commit the changes that the user made to the Salesforce org. This is something similar to what we have with Salesforce Mobile SDK, this smart sync technology. Let me show you here an example of how we used Lightning Data Service in our case. So here I have a candidate record page in our recruitment application. And our PM said, oh, you guys need to create a chart component, basically to do a graphical representation of the different scores that the candidate has for the different interview types. So we have technical, management, and recruiter, right? So we created this, and I want to show you how we reference Lightning Data Service inside of it. So it's candidate_score.cmp. So we used actually chart.js to create that chart. There is a Lightning-based component actually for chart coming down the pipe. If you guys look at the documentation page, the roadmap is public. But so far, we didn't have a base component for chart, so we create with chart.js. And then we decided that we wanted to use the Lightning Data Service, right, to be notified and to use the share record cache, make our component really performant. So because our chart component here lives on a candidate record page, we are grabbing the record ID by this force has record ID extension, right? The interface. So because we know of the record ID, whenever we instantiate this force record data, which is the base component for Lightning Data Service, we pass on the record ID parameter, the record ID that we grab from the record page. And then on the layout type, this is a pretty quick way to tell the data service that you need to grab the record from that candidate record in our case, but you need to grab all the fields that the user can see in the page layout. So if you specify layout type equals full, basically data service is going to return to you all the field values for all the fields that the user can see on the page layout. Okay. There's another way to do that, another attribute you guys can look at the documentation to specify the fields namely as well, but that's how we used. And I want to show you how this works. So let's make a change here to a standard CRM component, right, to this technical interview score. So let's change this to 10. And when we save the record, look at what happens with our custom component that is using the Lightning Data Service. So it basically redraws itself. It not only has a lot of performance gain, but the user experience gain is very nice as well, because it has this automatic refresh because it's tied up to the same record cache that all the platform CRM components is using. Okay, so definitely try to use Lightning Data Service as much as you can on your custom components as well. Now let's talk about that technique that I mentioned, that is how to dynamically create child components inside a parent from JavaScript code. So this is an approach that we learn when we start learning about Lightning Components development, which is to create most things inside the parent component's markup, right? So in this case here, we're looking at the parent's markup, and the developer here decided to instantiate 4 different child components inside the parent component's markup at once. That may be okay if these child components are not doing a lot of expensive stuff, and maybe you only have 4. That should be okay. I mean, providing that they're not making calls to the Salesforce server and so on. Maybe that's a good approach for that. But another best approach is to use aura-if, right? So aura-if, if you place the child components instantiation inside an aura-if tag, you're basically conditioning the creation of those child components inside your parent component's HTML DOM based on a Boolean attribute. So if you look at inside each or-if, we have a isTrue equals a Boolean attribute on the parent's components level. That's the best approach if you want to instantiate child components from the parent's components markup, because maybe the user doesn't even need to use one of these child components. You don't want to load all those child components into your parent's HTML DOM tree, right? That would kill the performance. Let's say you have 50 child components here. That or-if is basically the best approach if you want to create child components from the parent's markup. But the next approach, which is the one that we're presenting here, is how to create these child components dynamically, right, from the parent component's JavaScript code. So basically, one of the main benefits is that developers love the ability to write logic with if statement, and maybe you want to create a child components with different attributes inside a for loop. You want to analyze, you want to create a child component with one type of attribute or one attribute value, and others with other attribute values. So if you do this, if you create child components from the parent's JavaScript code, you gain a lot of more flexibility as developers. And also, you get the benefits of performance, because just like or-if, you're only loading and creating those child components if absolutely needed, right? You're not putting everything inside your parent's HTML DOM tree. Let me show you real quick how we use that in our case. So basically, I figured that I could recreate the same ListView component that we used for the session here dynamically, right? I could create all these ListView roles dynamically with this dynamic approach. So let me show you real quick. Okay. So basically, you guys can take a look. You basically need to set a body facet on the dynamic components body. And then from the JavaScript code in our parent, here is the facet. You basically use that a.create component to create the child components here dynamically. All the resources that I showed are on our session deck, on our record in dreamforce.com. We have the links to all those pages that I showed. So definitely check that out. I don't think we have much time more for questions, but I'm happy to take questions here outside. Yeah, can I take it here? Because they need to. Yeah. Thank you, guys.